So we have a data sufficiency question here, and it's asking if line K passes through quadrant 2. So by saying intersect, they're really saying, does it go through quadrant 2? And these are the quadrants of the coordinate grid mapped out. We have quadrant 1, which is when X and Y are both positive. And then we have quadrant 2, which is when X is negative and Y is positive. And then we have quadrant 3, this is negative, negative. And then quadrant 4, where X is positive and Y's are negative. So these are the 4 quadrants of the coordinate grid. And what it's really testing is a simple rule about coordinate geometry. And that is that any negative sloping line will always have to pass through quadrant 2 and quadrant 4. Because if you look at it, no matter if the line is extremely steep or extremely shallow, because lines go on forever, at some point, no matter where you put the line, it will have to cross through quadrant 2 and quadrant 4. But it doesn't have to cross through either 1 or 3 because it could go directly through the origin. And if it goes directly through the origin, it's technically not in any quadrant when it's at this point. So if it's going from 2 to 4, it could pass through 1 or 3, but it doesn't have to. All right, so what we know from statement 1 is that we have a negative sloping line, and the slope is negative 1/6. Well, because it's negative sloping, it will always have to go through quadrant 2 and quadrant 4. So in the blue, I've written out 2 versions of what is potentially happening based on that hint in statement 1. So we have a line that I've started up here, and it has a negative 1/6 slope. And so as you see, a negative 1/6 slope means it goes down 1 every time it goes over to the right 6. And so this is a negative sloping line. It goes down to the right. So if it's going down to the right, it's negative sloping. Up to the right, it is positive sloping. So what we see here is that it is already crossing through quadrant 2. So I know that it's possible to get certain lines that do go through quadrant 2. Now I'm asking myself, can I get any lines that don't go through quadrant 2? Because if I find that some lines don't go through quadrant 2, I've proven that this information is insufficient to answer the question of does K go through quadrant 2? So looking at this line down here, and if you imagine I even took this to an extreme and made it intersect the y-axis at like negative 1 million or something extreme like that, no matter what, it's going to eventually have to cross through into the second quadrant because it's arching up to the left infinitely. And quadrant 2 goes infinitely to the left as well. And so this idea of infinite space is what allows us to say definitively this will always at some point have to intersect with quadrant 2. So because no matter what happens, this will have to intersect with quadrant 2, statement 1 is sufficient. And that just goes back to that idea that any negative sloping line has to go through quadrant 2. Now the y-intercept, so looking at statement 2, the y-intercept of K is negative 6. Is that sufficient on its own? Well, I've drawn that out in green. And using an intercept of negative 6, I have shown that we could get a no answer, an upward sloping line that goes through quadrants 3, 4, and 1, but not quadrant 2. Or I could get a yes answer with a negative sloping line that goes through this y-intersect of negative 6, because in statement 2, it doesn't tell me anything about the slope of the line. So statement 2 is inconclusive. It's insufficient to answer the question, but statement 1 was sufficient. And for that reason, our answer is answer choice A.